Okay, so it looks like we are live. Hello, everyone.
All right.
Hi, Cedric.
Hello, everyone.
Yeah, so if you can see us, if you can hear us, please set the thumbs up in the YouTube chat and Discord chat, so we will know we are good to go. Pretty interesting content here today. So, how long, meanwhile, while we are waiting for the confirmation, Cedric, for how long do you work and do you use Kubernetes?
Oh, let me think. It's not long. I would say 2 years at most. But we did a pretty deep dive during the summer. So I extensively use Kubernetes, even if it's pretty recent.
Yep. And I started approximately 4 years ago, or maybe a little bit earlier. Our initial intention was to use Docker Swarm for that purposes, but those times Docker Swarm was not ready at all, and from the features point of view, it didn't do all the job what we needed it to do. So, how it goes for us? I see what we are good. If from our side video quality is very high, I see perfect connection and zero dropped frames, so we should be very good. If you have any kind of problems with the quality, please don't forget to adjust your YouTube settings, because you may need to set it to a higher quality.
Yes.
Good. So that's great to have you all here. Thank you so much for joining. That's DataStax Monday Learning, developed and delivered by developer advocates of DataStax. And today that's the final last class of our Docker learning path, and today we speak about Kubernetes. That doesn't matter if you join it us for the whole course or you jump it in right now. As long as you have understanding of how Docker works, this workshop, this class will be very useful for you to realize like why Kubernetes is in so high demand and why it's used so widely, but nearly all the companies those are using Docker containers in general. There are some competition, but I would say it was won by Kubernetes some years ago.
Yes, I would say now it's done.
Good.
Maybe I'm wrong,
Yeah.
but yeah.
Okay, so again, welcome to the last class. That's the introduction to Kubernetes. Final week 5 of the Docker containers from basics to Kubernetes. Originally it was from basics to best practices, but due to you asking us to add Kubernetes, now it's 5 weeks from basics to Kubernetes, not only to best practices. And important to know, if you just join it, all of our previous sessions are recorded, so you can watch them in any moment, and that's absolutely for free. And this course was a big success, as we got already over together 1,500 registrations. By yesterday it was over 7,000 views on YouTube, and altogether
Wow.
over 110 days overall watch time, and that's only those streams you've seen before. So that's
10
only
days.
grow.
That's cool.
Yeah, that's cool, and thank you so much for joining. So first few things we are going to discuss today. Container orchestration. So Kubernetes is a container orchestration tool. And before we start, I really want you to be not like this character on dilbert.com. People speak a lot of technical words, but what the purpose of our class is to get deeper and to gather real understanding of which problems it solves and how it works in general. This workshop is an introduction level workshop, so it's easy to learn, but you aren't going to be Kubernetes masters after that. But we will explain you what's the general field of responsibility of a Kubernetes, which problems it solves, and how to develop your further skills, so you will know where to learn if you are interested and want to make a deeper dive. Okay, so some of you attended our Docker learning path, and you may remember those pictures on the right. If you are going to run multiple containers, that's even on a single host, it's not going to be easy because there are a lot of dependencies. One has to wait for another. Mounting volumes, setting passwords, and so on and so on. So in general, that's a long story. Even when you run on it on a single host, even when you run it on your laptop, you may want to use container orchestration. And you know what? Docker Compose is the container orchestration tool. Most of you should know the Docker Compose already. And the really simple idea, that's a very simple tool. It's not for production really. It's for pretty simple use cases. But the main thing, it allows you to describe container configuration in a file and apply this file and make your containers running. So those are the basics of a container orchestration basically. And that's already better to use than just plain old Docker run.
True.
But well then, what happens if you speak not about your laptop, but about thousands of containers over hundreds of servers? It may be like 10 servers, it may be hundreds of servers, it may be thousands or thousands of thousands with ease, and amount of running containers may be tremendous for big companies. Kubernetes was developed by Google, and it solves problems for the companies also at the Google scale. So no surprises. It's not going to be too simple today, but you will manage that. When we want to handle orchestration of the containers on a big scale, we definitely need good tools for that. Here is a little link. There is a great comic explaining what the Kubernetes is at ease. That's kind of a vendor pitch for Google Compute Platform and Google Kubernetes Engine. Hosted solution or managed solution, we will speak about a bit later. I'm not selling you Google Kubernetes Engine, no way. But I do recommend you to watch this comic. It's really, really funny. But let's proceed. Which problem Kubernetes solves? Well, not only Kubernetes, there are some other tools. First of all, deployment and provisioning of the containers. We discussed it before on the previous classes, what in some cases provisioning of the containers should be done in some specific order, for example. And deployment of the containers must be done to some specific hosts or nodes. So they will be spread, for example. It makes no sense to run multiple instances of your service in the single node. On one of the nodes of a cluster. As soon as this node will be dead, power outage, all your instances will be not available after that. So for example, Kubernetes considers the allocation of the servers and will try to put pods to different servers. So even if one of the servers is not available anymore, still we will be running instances of your application. Also, upscaling, downscaling. Sometimes you need more. Sometimes you don't need so many computational power. Sometimes you expect Black Friday coming and you are going to sell the whole company, including board of directors. Then congrats. And that's again not easy to handle with plain Docker or plain Docker Compose. Health check monitoring and also self-healing. If one of the containers is not operational, we have to restart that. If one of the containers is kind of blinking, we may need to terminate that and bring it back. So things like that. Load balancing. It's not so easy to organize load balancing using just plain Docker. Here comes Kubernetes and its software-defined networks and load balancing, and that's a built-in feature that's really cool. So you can run multiple containers of the same service over your cluster, and that's for Kubernetes to take care of the load balancing automatically. That's completely transparent for the administration, for operations team, and that's great, and I love it so much. Then resources management and resources utilization. How much computational power do you have? Do you need more? Do you need less? Make proper load on multiple servers, not overload one single while others are idling. That's another point. Also, routing, make one service available for another service. So these kind of things. Publications, so make your services available from outside. It makes no sense in like, let's say, web application if you cannot access that. Then,
yes.
yep.
And you know, so all these features is really what is the meat of the container orchestration, and why you should use Kubernetes over Docker Swarm or Docker Compose, because those two only start containers one to each other, you know, side by side, but no real application logic. Whereas the orchestrator can say, okay, now this endpoint will be the load balancer between multiple instances of the same services. If one services crash, it will be restart. And if one services becomes slow, it can be scale out with a couple of command lines.
Yep. Technically, you can set up Docker Compose so it will restart failed services.
Yes, scale. Yeah.
But that's like a pretty plain, simple, stupid restart. Nothing like rescheduling of pods or like, yeah. Regarding Docker Swarm or Compose, so first, hi Arpit. Glad to see you again. I will answer this question in a couple of slides. Yep. And many other things regarding container orchestration. Without that, you would have to do it all on your own, and that's definitely not the thing you want to do. So yeah, that's a picture I really like. Sometimes management of complex system looks exactly like that, and now you are going to change that, and one of these knobs will lead to, I don't know, an explosion, and another will adjust what you need, but you have no idea in which order you have to change them. So container orchestration is the thing what helps you to do the things easier. I wouldn't say with ease, because as well, tool to manage containers at the Google scale, of course, that's not the simplest tool you are going to use. You know, there is a difference between tiny car, like just to bring you to a food store and back, and between big complex truck which brings like 40,000 tons to this food store, delivering something. So of course it's easier to drive a small car. So Kubernetes and his friends. First of all, there are multiple solutions in the field of the container orchestration, and I'm going to strike them out step by step. First of all, Docker Compose is not production ready and mostly probably never will be production ready. I know some small projects using it successfully on the production, but that's always about small projects. You may need something better. Helios. Helios was developed originally by Spotify, and now it's deprecated because Spotify moving to Kubernetes. So they accept only bug fixes, but Helios is not in development anymore and deprecated. Docker Swarm. It could have been a bright future for Docker Swarm, but we were too late. All the world needed container orchestration tools, and Kubernetes was in place already when Swarm was still not usable at all. And it was just too late, and it lost to Kubernetes. I'm not saying Docker Swarm is good. Docker Swarm in the modern scenario, nowadays, may be a good fit for small projects, especially as it uses configuration files almost directly from Docker Compose. So if you are using Docker Compose already, it will be pretty easy to convert to Swarm. But in comparison with Kubernetes, Docker Swarm is still not perfect fit for more advanced workloads. And there is a marathon measures, mostly the same story as with Docker Swarm. And now they're pretty powerful, but they definitely lost this battle to Kubernetes. So when we speak about container orchestration, I would say what Kubernetes makes like 95% of the market maybe. Do you agree, Cedric?
I do.
Yeah, I think that's like
Just
that.
reading.
Good. So, let's go. Next thing, you can use Kubernetes on your own with on-premises, and there are also some managed solutions. Nearly every big cloud provider suggests you to use their managed Kubernetes, and it's delivered by Amazon, by Google Kubernetes Engine, by Azure Kubernetes Service, and many others. Here is a thing to discuss: on-premises, hosted, and managed. What does that mean for you, and which option you should choose? I will not stay on that for too long because this course is mostly for developers, so I doubt if you will make decisions like that. But what you need to know with on-premises running on your own infrastructure and Kubernetes, you take care of everything. And when we speak about a hosted solution, like you can use AWS, Elastic Cloud machines, but you still can run completely your own Kubernetes there and manage it on your own. And of course, application is always on you. And you can use managed Kubernetes as well. For example, with Google Kubernetes Engine, it simplifies work, but it very depends on your use case. So I want you to understand where are the options. Will you manage Kubernetes and install Kubernetes and update Kubernetes, or will it be done by some cloud provider? And we can switch to Kubernetes Fundamentals. And we can go, I think. So, first of all, you cannot run your application if you don't have servers. In Kubernetes cluster, we speak about nodes. And node can be a bare metal machine, node can be a virtual machine, node even can be a Docker container. Speaking of, we put Docker in your Docker, so you can Docker while you Docker. That's of course not for production workloads, but more for testing and educational purposes. We will use that today. And then there are two main kinds of a node: master nodes and worker nodes. In short, master node is used to schedule jobs, schedule containers, and manage things. And worker nodes are more powerful nodes which run the containers and do the real job. And on the right side, you may see there is also etcd. If you don't know, etcd is, we can say, a database which is used by Kubernetes internally. But we aren't going to make a too deep dive, so we don't care about etcd at this step. So we have worker nodes, and there are some containers scheduled on worker nodes. And here is a trick. The point is, what the base unit in Kubernetes, the base unit you deploy, you operate, you terminate if needed, is a pod. And many people kind of lost at this point, like, what is the pod? Why use pod? Why can't we use container? Just normal Docker container. Short answer is, the trick is Kubernetes doesn't work only with Docker containers. It may work with RKT containers. It may even work with some special virtual machines, kinda as a containers. That's why pod is a wrapper for a container, is one just abstraction layer. And you see on the example of the right, we have Kubernetes node. So that's overall this blue thing. And we have two pods running on this node. And one pod contains only one container. And that's the most used use case when you just have one container, one pod as a wrapper over this container, and you are done. In some cases, you may have multiple containers per pod. Why? And is it a real use case? In short, yes. Typical example for the containers running in pod alongside to each other is a sidecar. For example, you maybe have heard something about Apache Cassandra. And I hope
Maybe.
if you didn't, you should, because it's a really great database. But not the point for today. If you run Cassandra in Kubernetes with Cassandra operator, you may notice what you have 2 containers per pod for Cassandra. What's the trick? Simple answer is one container will be explicitly Cassandra, and one container will be a sidecar. Sidecar is a special management process which you may use to retrieve, for example, monitoring data, some metrics, how it goes, is everything is fine with Cassandra, and so on and so forth. Containers running in the single pod, they share something. They may use shared volumes, they share a network, and moreover, they share inter-process communication. So, for example, pod A on the left cannot use IPC to communicate with pod B on the right, because they can communicate only via networking. But containers on the pod B on the right may use absolutely inter-process communication as well. In short, most of the time your pods will have one and only one container, and that's perfectly fine. In some cases, you may want to have a deeper relations between some of the containers, which kind of logically group it together, and you may want to have them within a single pod. In general, there is a very good rule of the thumb how to define if you want to put your containers in the single pod or you want just to have multiple pods, one container per pod. Think of scaling. Think if you want to scale, if you have container A and container B and they work together, think how do you want to scale them. If you scaling up always want to have as much containers A, as much containers B, then they are good candidates to be put in a single pod. If you think what you may need to have one instance of container A, but 10 instances of containers B, and you don't need things like inter-process communication between them, then mostly probably you just need different pods.
Yes, so maybe a sample. I will go back to Cassandra, if you don't mind. So Cassandra is the database, and you interact with Cassandra using the port opened by Cassandra. But Kubernetes needs some kind of probe to see if a container is up or not, or you may want to interact with Cassandra using an API. And so in the pod, we put a second container which exposes Cassandra in HTTP. This pattern is called a sidecar. If you have heard about sidecar, this is putting a container in the same pod as an existing one.
Yep, exactly. Okay, so I think we can move on.
Yes, and put us as a small head, I guess.
Sorry?
Make us smaller on the screen.
Oh,
we still big heads, and you are on top of the text.
Yeah, okay, so I will make us smaller. Boom, magic.
And phew, and now we are small. Yeah. All right.
This is kind of magic.
Yeah.
Good. So, pods in details. Pod is the smallest deployable unit in Kubernetes. You may consider pod as a container with metadata. Kubernetes needs to run that. And to configure pod, we can use secrets and config maps to configure pod. What's that? Secret is, as you could guess, password or API key you want to store secretly. That's one of the points to make control over with your authentication system, but we don't speak too much about the security today. And CM, configuration map, is just a list of key value settings you may want to have to configure a container. That's mostly about, for example, the environment variables we were speaking at the last classes. So secret about the confidential information, and config map is more about debug false, environment production, and other settings you may need to set up a container. Again, if you are using Docker Compose, for example, in testing and development, and Kubernetes in production, which is a very often used case, you definitely will need to change some settings for your application running in production. Oops. Then, pods management. You can manage pods directly, but it will be mostly the same as to manage Docker containers because, well, pod is a wrapper over container, we can say. A lot of work. To improve that, we use deployments. What is a deployment? Deployment describes a group of pods and their configuration, desired state, count of the pods you want to run, some settings for them, and so on. Then deployment controller, based on the configuration you gave to the deployment, will set up pods, will create replica set. A replica set is a kind of internal replication manager, let's say, which is in general suggested not to touch directly, but only via deployments. You can create replica sets manually, but it's considered a little bit of bad practice. So prefer to use deployments instead. In the deployment, and we will make a deeper dive as the deployment is one of the main tools in Kubernetes. We will work with a code directly. And it create replica set to scale pods up and down as needed. And how do we use all this beauty before we go to a first little practical example? There are two ways to communicate with Kubernetes. Via API, let's speak about the tools. Using kubectl direct commands and using files and infrastructure as a code approach. First one is much easier. So you can see examples on the right. kubectl is a Kubernetes control. It's a simple console command which uses Kubernetes API to execute the commands you ask that to do so. In the first scenario, we see just kubectl create deployment, deployment name, and which image we are going to use. That's not really useful. On the third example, we see something already more interesting. kubectl create deployment with the name my deployment. It will use image in Nginx. By the way, if you have been on the last class, you know it's a bad idea. You always need to use some text, not use the latest version. And finally, -- replicas is to set amount of pods you want to have to be running in general. And final example here is when we want to expose some port, then it can be done like that for the deployment to open port for that. But there is a better way we will discuss later. Networking is a special story. Then, second way to work with Kubernetes is infrastructure as a code. You write down in a configuration file using YAML what exactly do you want to have, and then you say just kubectl instead of create deployment. You say kubectl apply file. And that's a very great approach. And in general, I recommend, at least for production, definitely use this one, because it really allows you to have your Kubernetes infrastructure as a code, and you can completely use it, for example, with Git. And I cannot open all the stories because I still with some non-disclosure agreement from my former job, but I can tell you what having your infrastructure as a code under Git control helped us a lot of times in some special situations. In general, that's very great. It's really great when you can walk through the history of your infrastructure and see like, okay, 1 month it was like that, and 1 week later it was like that, and there were some changes, and when we run into some networking issues, for example. So with normal git diff command, you can see all the differences between your infrastructure within like the selected dates, and that's really cool. So there are multiple ways to manage, as you see. And I see in chat, hi Pranalim, what about using Helm? We usually use Helm for to install operators, like Cassandra operator is now suggested to install with Helm. It's not yet in the documentation directly as the recommended way, but it is a recommended way already, and we will add it in a couple of days, I think. So we don't cover Helm today, but you need to know what if you want to install operators, you may need a word Helm, and it's operator manager, let's say. Question one more. Can we use kind for production?
No.
No, no, no.
So kind means Kubernetes inside Docker. So I think you got the idea
Yeah.
here. Yeah, you won't. Yeah, it's not strong enough.
We use kind, and kind is a great tool, but only in learning, educational purposes, maybe for testing. Yeah, for testing
it's
a lot.
Like Minikube. Yeah, it's really like Minikube.
Yeah. Good. What exactly do you install for kubectl running? So with kubectl is a very simple story. Kubectl is a simple, small console executable file. So if you install kubectl on Linux or OS X, mostly probably it's going to be curl chmod plus x, and you can use that completely. So that's like a very lightweight thing. And yeah, so kubectl is just the client, exactly as Cedric says. Good.
Yeah, and I also shared the link of a bigger workshop we did on Kubernetes, multiple hours with hands-on deep dive, and you can follow those steps. It's working with Cassandra, but at least you do have everything you need to install on your laptop to have kind, which is a Kubernetes on your laptop.
Yep. Good. Then networking. So
do you know about so see the question here just before, do you know anything about GitOps and FlexCD? Never heard about those.
I'm not sure I understand the second question. Can we use Kubernetes on operator? Regarding GitOps and FlexCD, FlexCD doesn't sound to me. I didn't see that before. And regarding GitOps, that's the approach when everything is under Git, and that's like infrastructure as a code, and every pull request is the reason to do some jobs, run some tests, deploy something in Kubernetes, and so on and so forth. So yes.
Yeah, now even that's strange. Yeah, even Google does not know FlexCD. I just tried to find it, but yeah, so, I don't find anything regarding
GitOps is a very old strategy, very new word. At least that's what I've seen. Yeah, okay. I mean, all my life is GitOps, at least for last 5 years. So let's move on, and faster we go, sooner we can jump to a real code. So, Kubernetes networking. There are two cases for Kubernetes networking we want to cover: internal networking and external networking. And we start with internal networking. Imagine you have a group of pods. Every pod will have an IP address. Every pod will be running on a node. And mostly probably we are going to run on different nodes. Question is then, how are you going to connect pod B to pod A? You need to make some kind of routing. You need to somehow to connect them, maybe using IP addresses. And then don't forget, pods are ephemeral. Today you have 5, tomorrow you will have 8, tomorrow you will, the day after tomorrow you are going to have 800 of the pod A kind. So there is a better way. We trust Kubernetes to handle networking for us. Service is a network abstraction used to expose an application, group of pods, as a network service. In short, you have your service, I don't know, whatever service, let's say it's a Python web service, just for example, it can be whatever you want. And you want to have free instances of these pods. So you specified in the deployment what you need, free instances. Okay, and then you define a service over that, specifying what it will match this set of pods and this port. And as a result, after that, you don't have to, your other pods don't have to know nothing about this Python web service, for example. They just need to know the name of a service. And that's it. And then they ask for this service. It's a simple DNS call. Then Kubernetes will automatically calculate which node and port now to use for that. And there is a load balancing as well. So that's a real DNS request. I'm going to use Web Python. Let's say our service is called Web Python. Very easy. When we just ask DNS server for which port I'm going to ask, it gives me the address and my client goes to this one. And that works really good. We consider service as a kind of facade for a group of pods, and service also may provide load balancing. Another point would be external query. So we can configure service to be also available from outer world, from the internet. But in general, that's a bad practice. So that's always better to use ingress. Ingress is an entry point for external connections. It's kind of a router what accepts incoming queries and routes them to a proper service based on the defined rules. So you may configure ingress to say what if someone asks me for my favorite application.com, then the query has to be routed to service A. And if it asks for another great service.com, then the query should be routed to service B. And well, there are very many different setup options and configurations, but in short, Kubernetes ingress is an entry point for the outer connections with routing, so you may specify which query goes to which place. On production, mostly probably you are going to use ingress. On testing and development purposes, it may be easier to use service open to the outer world. And we are getting very close to the end of my overview, so we can jump to the real code. Kubernetes persistent data. So, what's the story behind persistent data? The trick is it's not so obvious and not so simple to work with persistent data you want to store even if your pod was terminated in Kubernetes. So here on the right we see a little sham how it works all together. First of all, to work with persistent data, you are going to create some persistent volumes. And every volume needs to have a storage class. Storage class depends on the environment you are working with. So it will be different if you work on like bare metal Linux server, your own on premises, or if you work with Google Kubernetes engine, storage class will be different, for example. Then pod may make a persistent volume claim. So that's kind of a request for the persistent volume. If this persistent volume claim can be executed, and so you have persistent volume available for this pod and for this claim, then this persistent volume will be arranged to this pod. So that may be not as simple as we work it with volumes using Docker. As it is, persistent data is a long story in Kubernetes, so if you are going to use it on production, I do ask you and I do tell you this introduction level workshop is not enough and you do want to make a deeper dive. But for the overview purposes, that's for the beginning will be enough. And a little bit of overview how it works in the real life and how your application looks running in Kubernetes in the real life. That's the simple application example with the persistent storage. Oh, sorry, that's a typo. That's not a persistent storage, but with a configuration. What we see here, that's a simple schema we have. That's our application, just myapp.com. It's a stateless for the simplicity. And in the beginning, you see the ingress. Ingress receives all external queries. When you have service, this SVC is an abbreviation for service. So you can, so we see what ingress sends all the queries to a single service. Behind service, we see a group of pods, 3 pods in this case. Those are managed by replica set, defined by the deployment. You remember, yes, what deployment defines groups of pod, and deployment controller creates replica set to establish replication for them. This one is a bit transparent, so don't make too deep, too much on that. For now, that's not important. Then finally, we have some secrets allocated to these pods and config map allocated to this pod as well, so we will share the configuration. That's a very simple example. Usually things look like more sophisticated. Mostly the same example, but with a persistent storage already. Higher level will look the same: ingress, service, group of pods managed by deployment. And now we have this persistent volume claim allocated for the persistent volume, and persistent volume has storage class.
We do have a good question again from Arpit. Thank you for being there week after week. So what's the difference between a Docker volume and a Kubernetes volume? And so in my, you will complete my answer, but in my perspective, so Docker volume is really a folder somewhere, in your file system, just mounting a file system. Whereas in Kubernetes, a volume, persistent volume, has a real specification. So it's not only file system. So it's use storage class as defined by Alex, and you can have multiple implementation of this persistent volume. You can use EBS block storage. You can use, depending on where you are, which cloud you are using, you will have not the same implementation of this volume. Why? Because maybe you want IO, very high throughput, and you will have dedicated type of volume, maybe SSD, just to be as fast as possible, but it's more expensive.
Yep. There is nearly nothing to add because you explained it, mostly all of that. The point is, when you're using plain Docker, mostly probably like 98% maybe, your volume is going to be just a folder. In the deeps, but usually it's just a folder. Well, maybe not 98, but around 92 or something like that. But there are other drivers. So in some cases, you may need to use another kind of a storage, and it's absolutely possible with Docker. But usually it's just a folder. And as Kubernetes is a production-ready tool, you can use different storage classes, mostly probably depending on the platform you are using. On premises, it will be this one. On premises with network attached storage, it will be another one, and so on and so forth. On Amazon, it will be different. So that's already platform specific. Good. But all of those were simple applications, and this one looks a bit more advanced and more realistic, to be honest. For example, here we're working again with a single ingress and only one service behind that. But this service, which is a main service for us, the application, will also work with a database. Notice there is no direct connection between ingress and database service. Why? Because you don't want your database to be available outside. Only internal network connection is supported. So it's kind of a security question. But also application may use another services. So in this case, it uses only one simple example backend service, which, I don't know, maybe caches some information or executes any another job. And in most of the cases, that's exactly that how application looks like. Sometimes simpler, sometimes harder, but that's how it usually looks like. Of course, with persistent volume claims for database. It's out of the scope here, it's not shown, but of course, your database is going to use persistent volumes. And one more thing I didn't mention before is the namespace. Again, as Kubernetes cluster may work with dozens or maybe hundreds of different applications communicating with each other or standalone, you don't want to have them all together running in the single namespace, in a single space. We use namespaces in the Kubernetes cluster in Kubernetes to isolate some logical spaces one from another. For example, you want to isolate one application from another one, or you want to isolate monitoring part of your system from the production part of your system, so they will be isolated. That's not even so much about the security, but about manageability, because if you ask like kubectl get services and you have 10,000 of services running, it's not going to be easy to handle them. So namespaces are about logical grouping of the things. And oops, okay, I see. No, we are just starting. Good. So, and then let me dive to the next thing we are going to cover today. So, yes, we can run things using direct kubectl commands, but we in general should tend to use files. And how does these files look like? Let me show you. So, you have heard maybe about Killer Video. Killer Video is our Killer Video. No, it has separate case. So let me switch them. Killer Video.
And I copy paste the link in the chat.
Thank you so much.
And also the all-in-one, because this is probably where you are
Exactly,
going.
you know everything, of course. Thank you. Yeah, so we have Killer Video all-in-one repository. And that's... So if you don't know Killer Video, very simple to explain. It's our demo application, reference application, showing how we work with Cassandra, Apache Cassandra, and DataStax Enterprise. Today we will use it for the demonstration purpose, to demonstrate how it works with Kubernetes, just because it's a pretty nice architecture. In general, Killer Video you can consider as a YouTube, for example. So it's kinda a video hosting. It's a demo application, so please don't use killervideo.com to store your real files. But
it's a clone of YouTube.
Yeah, it's a clone of YouTube. So I will make it bigger. Hope you can see that.
Yeah.
Yeah, looks pretty good. So we start with Docker Compose, just to make it easier to realize before we proceed to Kubernetes manifests. So that's a Docker Compose YAML file, which describes how application looks like when you run it on a staging, when you run it on a testing or locally. We have some services we need to run. For example, web service will be web frontend, of course, and backend will be, as you could guess, backend, so backend services. We may need also Studio to manage Cassandra, as it's a demo application to work with Cassandra. We are going to have database, because we need to have database, of course, and a couple of more services I don't want to discuss right now, because that's out of scope. We speak about the Kubernetes today. But there is nice, interesting thing to mention. DSE config is a one-time bootstrap container. We want it to be executed only once, not run all the time in the background. So how it works, I will show you in a moment in the Kubernetes files. There are some options you may be familiar with, and some maybe not so familiar to you. Let's take a look. So image port depends on environment. That's all understandable. But what's the label and specifically compose service type node port? That makes, what does that make? Very easy. There is a special tool called Compose, which allows you to convert your Docker Compose files into Kubernetes manifests. And that's really cool. You still have to be very careful because after this kind of conversion, it will be production ready. So you need to walk through them and see. But if you just want quickly to convert from Docker Compose into Kubernetes manifests, and you are fine if there can be not if there may be some scratches, let's say, then this Compose is nearly perfect tool. It's very smart, so it converts everything what we describe here like that. It will use image for the deployment. Exactly this one. It will expose ports, and it will create service based on this definition. Push some environment things into the deployments and so on. But Docker Compose does not allow you to set some special settings for service, for example, because, well, it's a Docker Compose file. It's not for Kubernetes, technically. So if you want Compose to give Compose some hints, like how do you want to have your service, in this case, when we just use labels. For Docker and Docker Compose, they change nothing, because those are just some metadata for it, like not real data. But Compose knows what if it has like compose.service.type, then service for this deployment needs to have type node port. What is it? I will show you in a moment. And mostly the same for some other things. We will use node port for Studio, and I think that's it. So we can proceed finally to Kubernetes manifests. So there is a folder called Kubernetes. Oh, by the way, we didn't explain what does that mean. K8S. It's just abbreviation. That's exactly Kubernetes, but people are lazy to type Kubernetes all the time, so they cut off 8 characters from the word Kubernetes, and now everyone writes that like K8S.
Yeah, or KTES.
KTES, yeah, you can read it simply as Kubernetes or KTES, doesn't matter, it's all the same. So here we have all the files created by Compose for our deployment of killer video in Kubernetes, maybe with some minor adjustments. And that's interesting. What in general you can put it exactly to one single file, but it will be too big. You will see what Kubernetes manifests are too big. And what we want to have here is maybe a little bit smaller files, easier to understand. So, for example, at first we can take a look at a pod. As you remember, pod is the smallest deployable unit, base unit in the Kubernetes you can manage. And that's Kubernetes manifest we work with, and that's a very simple one. So every Kubernetes manifest always starts with some simple definitions. First, which API version it's going to use, which is mostly V1 so far for the simple objects like pod. Then kind, what is it exactly? This one is pod because, well, it's a pod. If it would be service, then it will be a service or deployment. We will see it. Then there are some metadata. So some meta properties of the pod we are going to create. Creation timestamp is null yet. We will have labels. In this case, labels is a simple thing, as Compose creates this file and copy-paste all labels you have to the labels of every configuration file it creates. And the name of this pod will be DSC config. It's just a name. But Then there is more interesting thing, which is a spec, so settings for what we are going to have. It will have containers, and it will have only one container. For this one, we don't need multiple containers. Image we are going to use. Name of this container, it's a kind of optional. This one can be cut off. And restart policy on failure. As it's a single run setup pod, which technically should be done by job in Kubernetes, but job's out of scope for this workshop. We just run a pod to do all the setup job for us. And it has a restart policy on failure. That's important. It means what if pod container in this pod exits with exit code 0, which in Linux world means success, this pod will not be restarted by Kubernetes because restart policy is on failure. So we start pod, it runs, it exits. If it exits with exit code 0, we don't touch it anymore. But that's a rare use case. Mostly probably you want your containers to be running longer. Here comes the deployments. At first, I will take a look at the web deployment and web service. So, and here is a very important thing to understand about how Kubernetes works. Selectors. But first, let's speak about the deployment we have. So, metadata must...
Yeah. Can you zoom a little?
Oh, one more? Okay.
Yeah.
I hope it's better.
Yeah.
Good. So,
it's a bit too small.
First, metadata. So, labels, you know, it comes from Compose, it doesn't matter. Name of this deployment will be web. And we will have some annotations there. So how exactly it was created by Compose. That's a Compose artifacts. Usually you don't see it too often in the Kubernetes definitions. Then we have already interesting things. First, how many replicas we are going to use. By default, as we don't know where exactly these Kubernetes manifest web deployment will be executed, we set it to 1. If you run it on production, mostly probably you are going to adjust this value to some higher numbers. Specs we are using, this pod of these deployments will have only one container. So we are using only one container. It will have environment killer video logging level equals debug. So that's just copy paste from Docker Compose YAML file. And that's what I speak when I say what Compose is not like for direct usage on productions. You may mostly probably want to adjust things like that. When which image we are going to use and which name it will have and which container port we will open to be available at this pod. And we may switch to web service. And actually I will need both of the files because that's a very important thing to understand how selector works. So notice these speaking of metadata, these pods of this deployment, it has name web, and container has name web as well. If we go to web service, do you remember what the service is? Is a facade, kind of front end gate for the pods of a deployment it works with. And in this case, we have an important thing. This one. So, first part defines the service as it is. Which port will be open? Port 3000 and target port 3000. So, as a target port on the pods we are working with, we will use port 3000. Also, port 3000 will be default port for this service. Very easy. And now comes very important point. How service understands which pods it uses, with which pods it works due to selector. And that's a very common technique in Kubernetes. You have some services working with another based on the selectors. And selector, in this case, you see io.compose.service web. Where does it come from? We have, where is it? Oh yeah, labels. We have labels here, io.compose.service web. So that's a very simple selector based on labels. It will work with all the pods labeled like io.compose.service web, and we see it in the selector. So as a result, this service will automatically be a frontend for all the pods with this label. You see right here. I don't cover it? No, I think I don't. Good. And finally, last setting, service will have type not port. And node port is an interesting thing. From one point of view, node port is one of the widely used service types in Kubernetes. From another point, you should never, well, maybe not never, but try not to use it in production. What does that mean, node port? It means this service will be available not only internally, but also externally on port 3000. And as a result, when you have files, when you have a service available running at this node A, let's say you have 3 nodes, node A, node B, node C. If your service, if your container runs at the port node A, it will open port 3000 at this node. What's the problem? First of all, your node has only one port 3000 or any another port only one time. It means what you cannot just allocate second port using the same port. It will be blocked already. It will be in use. Another point, what for example, you are going to have multiple nodes, one instance of this service available, like let's say it's stateful and you can't run many of them. And then today this pod runs in the node A. And tomorrow node A got some troubles, like maybe some issues with disk or whatever, and pod has to be reallocated to another node. What happens then? IP address changes, of course, and you have to reconfigure external services using this service, which is obviously in many cases maybe a very, very, very bad idea, especially if you don't manage them directly. So we do suggest to use node ports only in the scenarios like development, testing, maybe some special kinds of staging, but in general, staging should look like your production infrastructure, and therefore it should not have node ports. Try to avoid them. How to avoid them? Use ingresses. Very simple. That's for testing, so we don't use ingresses here. We use just node ports because it all runs usually on a single node. No problems. Good. And then some more things to consider here. I told you about them. So other pairs will be similar. If this application has to be accessible externally or internally, it will have service. Web service has service because it's available from outer world. Backend deployment, backend service is needed because web service will access backend, so it has to be opened, but it doesn't need to have node port. It has no node port. Why? Because backend should not be available externally. We don't need that at all, but we still need service. And there are some more cases, for example, like, where is it? Generator. Generator deployment, it's a special service for killer video, has no service at all. Why? Because it only executes, it never answers your questions. It always asks questions like create that, create this, write a comment, and so on. So as long as no one wants to communicate with generator, I don't need to have a service. That's enough for me to have the deployment. Okay.
Can you say a word about the version? You know, API version v1, API version v1 beta. You know, first line of the YAML file. So as far as I know, this is simply version number used by Kubernetes for validation of the file and try to cope with version of Kubernetes you want to deploy.
Yep, exactly. So take a look. API version explains to Kubernetes where to look for the definition and processors, let's say, for this kind of manifest. In this case, we use manifest kind deployment. And this API version is actually, I guess, awfully outdated because it was added approximately 2 years ago. Yes, it was added by me 2 years ago. So now recommended API version for the deployment will be different. And there is a very interesting point to notice about API version. In some cases, it may be just v1 because we work with pod. You remember pod has API version v1 because it's the base unit in Kubernetes. So it's a built-in type. But if you work with more advanced things like extensions for Kubernetes, custom extensions, not built-in types, but for example, operators like we speak about Cas operator, that's the operator we use to work with Cassandra in Kubernetes, of course. So we may find, give me a moment, I will find Cas operator, that should be this one, I guess.
Do we really introduce the operator concept?
Not in this workshop, because otherwise we will over tonight.
Yeah, I agree. So just for everyone, if you are new with Kubernetes, so in Kubernetes, there are multiple types of resources. We talk about pods, which is the default and basic one. There are multiple kinds of resources. Could be config map to store your keys, could be secret to store your password, could be replica set if you want your pods to have multiple instances. That's not the point. Those are default and basic resources. But at some points, you need some custom behavior. With Cassandra, for instance, this is the one we know best. When you start a cluster, you want to start node one after the other. This is what we call node bootstrapping. And if you tell nothing to Kubernetes, Kubernetes will try to start all the nodes at the same time. So we need to tell Kubernetes how to interact with our application. And to do that, we are using custom resources. Okay, so those are called custom definition resources. Never mind. And we need an operator. And this operator will really listen what is the state of the current application and interact with it. And we need that intelligence on top of basic resources from Kubernetes. And this is brought by an operator.
Yep, exactly. It may be not the best comparison from the technical point of view, but it really explains why do we need operators in general. You can consider every operator as a management tool for some specific application. So it's kind of a package manager, we can say. Well, it's more Helm like a package manager, doesn't matter. But if you want to install Grafana with some default dashboards, the Grafana operator will do it for you much better than you could do in the beginning. Cassandra bootstrap and management is also not a simple thing. That's why we use Cassandra operator to simplify operations with Cassandra on Kubernetes at all. So my point was, if we open example Cassandra data center, that's the beginning of a file. Every Kubernetes manifest starts with 2 lines: API version and kind. Kind says what is it this manifest about, and we say Cassandra data center. That's the custom resource definition introduced by DataStax, of course. And here we see API version. So API version helps to Kubernetes to realize who is the owner of this kind and where are the information, how to process it, what has to be done when we create a Cassandra data center. Because if you would say like API version v1 kind Cassandra data center, Kubernetes cannot do that because Cassandra Data Center is not a built-in type, of course. It's it's just not a built-in type. So we say here Cassandra Data Stacks.com v1 beta 1, and therefore Kubernetes knows what this kind of resource, this manifest, goes to Cassandra Data Stacks.com. So Cassandra operator must be installed to process this kind of definitions. I hope I've answered this great question.
Yes, you do, and more questions are coming regarding performance of Cassandra inside Kubernetes. You know, it's like a virtual machine. It's not as fast as bare metal, but you know what? Also, what is neat with Cassandra is horizontal scalability. You want more small nodes than bigger nodes. So yes, that's slower, meaning in Kubernetes, it's still virtualization. You can find some pretty fast storage class. Remember the persistent volume to interact with your data using SSD, but that's still slower than bare metal. You bring some flexibility with virtualization, but you miss a little bit of performance.
Yep. Pranali asked, is it the same operator? Is it the same as an application? So basically, operator is an application, but we call it operator because it's created to do some maintenance job on Kubernetes for you. So Cassandra operator knows how exactly to install Cassandra, as we speak about Cassandra operator, which settings has to be done, how to better run a rolling reboot, and so on and so forth. Good. I hope we answered this one. So,
yeah,
and now finally, I want to do some practical steps because, well, that's time goes by.
Talk is cheap.
Helm is an operator manager. So with Helm, you install operators and Kubernetes applications as well. Does Kubernetes fail a pod? Then associated storage claim has issues, for example, corruption. Wow.
I think it all depends on the liveness probe. So Kubernetes will interact with your pod using some probes just to see if the pod is running and if the probe is LC. 2 probes, 2 HTTP call. So if your disk is corrupted, that means that the else probe of your pod should take that into account. I don't think Kubernetes by its own try to interact with your volume. So this is really part of you when you build the else probe to be aware that the volume should be there. I think.
Yeah, that sounds very reasonable. Data corruption. First of all, this kind of a corruption. You may use old school hard disk drive and have some failed bit on this hard disk drive. That's one kind of a corruption. Or maybe there may be some result files written in a wrong format and so on. So it's also data corrupted, but I doubt if Kubernetes should react on that. So that's in general about monitoring for events, which is out of scope for the Kubernetes for developers. And
yes, and thinking about DP, great question, DP, today.
Yeah.
You put me on the spot answering your question, to be honest, but that's very good. I also learned in the process. Is it too much to handle by app developer? Maybe those discussions should be done by both people from productions and developer, because the guys from the upside probably have a lot of procedures, monitoring tools to handle these pods and Kubernetes resources, and you will probably follow the same path.
Yep. I would say, take a look. Write applications as we used it to write before, and write applications to run on Kubernetes may require different and more knowledge from developer side. Absolutely. And we can consider it as a disadvantage as long as we don't get a higher paycheck. So Kubernetes enabled developers who care about how their application will run and understand some nuances. Of course, they are higher paid than developers who doesn't care. So there are no doubts. For me, it's fine because I always care.
Yeah, but you come also from the ops.
Yeah, I have
dark
ops
side.
background. Mostly, probably that's why I care. Okay, so we can go with then a little demo. So, and first thing about how to run Kubernetes. Again, we always say that's not enough to listen to us. You always have to put your hands on and do your job, and that's the only way to learn it better. There is no shortcuts. That's on just go and do that. And we have some options. First of all, a very good way to run it on your own machine, as long as you have Docker installed, is kind. Kind is literally Kubernetes in Docker, and that's the test environment and development environment. You do not want to run kind on production. Kind is a pretty funny thing if you think about that. Kind create special Docker containers. Those behave like Kubernetes nodes. That's pretty funny. And you work with them, and they answer like Kubernetes nodes. So you work with them using kubectl. Installation of the kind is pretty straightforward as long as you have Docker installed and Docker Compose. There is my installation point. Quick start.
Brew install kind.
Boom. Here we go.
Welcome.
So on Linux and on Mac, it's usually like that. You just copy paste latest executable file, set the executable bit on that, and you can go on.
Yes.
And that's it.
And remember, I will provide a link in the chat where how to install all these tools, because those are part of the longer Kubernetes environment.
Yep. So when I have it right here, and let me make it a bit bigger for you, I have kind installed. So it's very easy for me to use. I think it will be fine. And I create a cluster for myself with there is a file kind config, and I'm going to adjust something here. So we don't need that. We don't need that.
Yes, so
we don't need that.
We are using kind. Maybe you have also heard about Minikube. This is another way to run Kubernetes on a single machine. Why did we pick kind? Is really because with kind, you can have one Kubernetes master and multiple workers. And because we are doing demo with Cassandra and multiple nodes, it's easier for us to have multiple workers.
Yep. So Minikube isn't bad, and if you want to have, if you are fine to have only one node in your cluster, which is again for development purposes usually enough, then you're completely good to go with Minikube. In our case, kind works much better. So here we have my cluster definition, which is first kind cluster, API version kind x Kubernetes IO, so we know that's an extension, and we are going to have some nodes. In this case, we are going to have 4 nodes. One will be control plane, so master, and we will have 3 workers. And here is a kind specific thing. If you going to use node ports with kind, and kind runs Docker in Docker, As a result, your node ports will be opened to a Docker container, but will be not available from your host machine. So in this case, to make application available for outer world, my node port services, I'm also has to use extra port mappings to forward port 3000, which is going to be used by my web application. And I'm doing that for every node because there are no labels, and I don't know which node will have my web application running in the end, because it may be randomly allocated for one of them. As you see, I have some space for improvements here. Okay, so now I'm going to apply this file, and this one I'm doing with kind. Don't forget, we aren't reached yet kubectl. And to create a cluster, I go with kind, create cluster, name will be test, and config will be in config.yaml, which I've just created. And kind starts to create my cluster. It will be pretty quick because the image is downloaded already, so we just need some seconds to start up the nodes, and we see what it starts, 4 nodes, so 1 master node and 3 workers, and it's going to be something went wrong. Okay, what was wrong? Ports. Okay, I already have something running here. That's weird. Okay, I think I've cleaned that. Kind delete cluster name test. Name test. Kind test. Okay, so kind get clusters. No clusters found, so I think I can repeat this query. So that was a short answer. Could I use kind on production? No. Yep. But besides kind, while it's installing, I want to show you a couple of more options. I'm only curious, is my port free? Okay, it looks like my port is still not free, and that's a bug, because it is free, port is not available, address and ready use, funny. But okay, I know how to fix that. So that doesn't matter. That should not happen for you, but may happen to me. I will simply use another port. And my host port will be 3100, so I can create it again. So, okay, while it's creating, let me show you something different. Another option to use to play with Kubernetes is labs.play-with-kubernetes.com. I will copy paste the link. Good, it's in the chat. That's the tool you can use, like you've seen already play with Docker, maybe. You can use that play with Kubernetes. And that's the same idea. Kubernetes as a service, don't use it for production workloads. All the nodes will be terminated within 4 hours. But to play with Docker, it's very good. And you can have multiple nodes, which is nice. For example, I've used node 1 to initialize Kubernetes cluster using kubeadm. Kubeadm is a built-in Kubernetes tool to set up cluster, of course. And I believe I created router already. So now I can use suggested command for on other nodes to join. So now if can you see that? Is it big enough?
It's a bit small for me.
Okay, I will try to make it bigger. Hey there. Just a second. Oops, get back. Okay, now it's too small for me. But okay, I will try. And then Cassandra. Kubernetes cluster was initialized, it suggested me which command to use on other nodes I want to join this cluster. So if I now say kubectl get nodes, we will see only one node, which is kind of not ready. So mostly probably I want to restart that. Or I will simply run a new session, doesn't matter. But anyway, on the next, no, you know, I really want to start a new session to show that connection has been lost, of course, because session is closed. To log in onto Labs Play with Kubernetes, you may need to use your GitHub account or what was that? hub.docker.com account. Okay, so now it's refreshed. I'm adding some new nodes. Hey there, where's my node? I'm really afraid to reload that. So last time I tried to use Play with Docker, it was also behaving like that. In general, local usage is of course always better. And finally, so it doesn't create any instances for me. Thank you so much. Finally, if you it's a caching problem. It was the same with Play with Docker. If you cannot use, by any reason, labs play with kubernetes.com and you can't use it locally, write me an email. I will send you a Linux machine with kind installed, so you will be able to use that on your site with no problems. Yeah, because this doesn't work to me. That's stupid. That's funny. This morning it worked very well. But okay. Yeah, it's the same session ID, and I guess it will not create. Oh, yes! It created a node for me. Great. So I now kind of have two virtual servers. First one, I'm going to initialize cluster master node. So where are the commands I need to use to make them running? It may take some moments because to run Kubernetes cluster, Kubernetes has to pull some Docker images. So meanwhile, we can jump to my... And that's something very wrong is happening with my kind. That's incredible. Okay, I have plan B. Doesn't matter. Plan C already. Response from daemon ports are not available. Address already in use. Ah, of course. That's my bad. Because host port has to be different. That's easy. 3000, 3001, 3002. That's it. I have only one machine, of course, so that was the problem. Okay, I have to delete. Good, and I can create it again. That was on my side. Don't blame kind, I'm sorry. So, meanwhile, our first node was initialized. We need to execute one more command to initialize cluster networking. Otherwise, network will not work for me. This one is going to be very quick. It's done, and now I can join any number of worker nodes to my cluster, and that's the command suggested to me by Kubernetes. That's going to be kubeadmin join IP of my machine, which port to use with some tokens and discovery tokens. Now I can go to node 2, and I will use even one more. So I go to node 2, I copy paste this command kubeadmin join. It again will take some time. And I will run the same on node 3. How it goes for this gentleman or lady, I don't care. So it looks like they are joining, waiting for the kubelet to perform the TLS bootstrap. And I can try to ask kubectl kube control get nodes. Okay, so perfect. It works already. By the command kube control get nodes, I get the result. What I have 3 nodes. One is master. Age is 105 seconds. And I have 2 nodes. Those are not masters. They are not ready. Of course, because they are bootstrapping. Okay, second one looks ready and third one looks ready. So now if I say get nodes, okay, second one is ready already. Now there is an interesting trick. Please think a little bit. Try to guess. It's hard to answer, don't worry. Does it have any kind of running pods in this moment? Cedric, you know the answer. Wait a second, let them think. Write an answer in the chat.
Yeah.
Do you think there are some pods running or not? I will check meanwhile. No space left on device. Okay.
So no, there is nothing running.
Nothing running. My God. So locally, it's not a great day today.
Docker system prune. Come on.
That okay. We still have web version, so it doesn't matter. And third node is still not ready. I don't know what happened to that. The node has joined the cluster, it says. But okay, this node will be enough for me. Interesting what happened to that, but that would be enough. So, meanwhile, answering questions. Answer is complicated and not so obvious as you may think. If I say kubectl get pods, it will answer no resources found in the default namespace. But if I say kubectl get pods all namespaces, we found out what we have pretty a lot of things running. How it comes? Why do we have pods running already? Answer is there are service mechanisms in Kubernetes as it is, and all of them are also running as pods. So Kubernetes as it is a set of pods, and that's pretty interesting moment. Now I see some of them are ready, some of them are not ready. Let's give them a moment to bootstrap. Maybe they need a longer time, or I may add one more node. Let's walk through the technical things we have here right now. And what does that have? Core DNS. What does that mean? Do you remember we discussed service auto-discovery, routing, and so on and so forth? Kubernetes inside has real domain network system servers. Those answer your queries. So core DNS is a real domain name server answering queries. Then etcd. I mentioned that in the very beginning. etcd is the database Kubernetes uses to store config, again for service discovery and some more options. Then we have kube API server, so that's API server running on the master node, which reacts when you do kubectl. Kubectl makes a request to API server using Kubernetes API. Then we have kube controller manager. Well, that's the controller manager, the brain, let's say. And then we have some proxies and routers and the scheduler node. So let's take a look at another thing. First of all, no container creating in it. So it looks like those not running will be launched at some moment. But now let's take a look on a better thing. I want to see which nodes are those pods running. And I can say -o, so for options. And I can say option white. Option white means what for get command, I will get a bigger output, so some more details. And now I can see what they're running on different nodes. And let's take a look at the thing. If I tell kubectl get pods, and I will grab for node 1. Do you remember? Node 1 is a master node. We will have some things here, like core DNS, etcd, API server, controller manager, proxy, router, and scheduler. Pretty long list of the things. But if I run the same command, looking for the node 2, answer will be much shorter. Why? Because node 1 is dedicated for management over cluster, and node 2 is dedicated to execute pods, to keep nodes running. Usually worker nodes are much more powerful, and usually worker nodes don't need so much processes to run. They use router, so it's a part of a software-defined network in Kubernetes. So every query comes to this node will be dispatched to a proper container, proper pod. And it's all processed by proxy. And if you would ask for node 3, I guess answer will be the same. If we will get any answer after, yes, after all. Okay, so something goes wrong with a node 3, but we don't care so much. It's just not started yet, although 6 minutes, it was enough. Good. And I will try to start with this one. So first of all, I'm switching to node 1. And I will need to have my killer video all in one file. So what I'm going to do is simply git clone this file, this project, to my Kubernetes enabled application. So git clone address, and that should be enough. Luckily, this node has git installed, so no more steps for me to do. And I can switch to killer video all-in-one, and I can switch to Kubernetes folder. And there are two main ways for us we may run application, as discussed before. Okay. It's weird, but okay. Okay, so we can execute direct commands, or we can apply files. So in this case, we can start with a very simple one. We can do kubectl apply, and apply first a simple file before we proceed to killer video. And before we go there, let's take a look at the definition of this file. So I'm not executing this kubectl apply, but I just open this file. And I will make it a little bit smaller because it's too big. I hope for you as well. Mm-hmm. And we see, first, it has only two definitions. Single file, two definitions, perfectly fine. One is deployment, and one is service. Both have simple API versions because those are built-in definitions, built-in manifests. First one we create, deployment. Name will be my Nginx, and labels will be app Nginx. As you will work more with Kubernetes, you will meet that more and more often. That's like very traditional to separate applications, deployments, pods for selectors using app equals something. And when we have a specification for this deployment, we will have 3 replicas and a template for the pods of this one, because deployment is defined with template, and this template defines the pod, which pods will be created. It will have metadata, labels, app Nginx, so every pod will have label app Nginx, and it has specification. Every pod will have one running container, one and only one. It will has name Nginx, image Nginx 1.14.2, and it will have container port 80 open for the service. And now we can proceed to service. That's service. First, don't forget, important thing for us is selector. We know what it will choose all pods where label app will have value Nginx. Very simple. And this service will have type load balancer, so it will not just throw randomly queries to the pods available, but it will also have some balancing. I don't remember what now in Kubernetes, I guess that's kind of round robin. And finally, it will has port 80. Pretty obvious. So let's execute this command. Okay, so answer is simple. Service, my Nginx service created, deployment, my Nginx created. Now we can say kubectl get pods. And we see our pods are running. That's quick to start Nginx. And then we can say kubectl get, what else could we take a look at? Deployments. Deployment, sorry. And we see we have only one deployment, and with default namespace, call it my Nginx, exactly what we created right now. And finally, if we look for services, and here notice, instead of full names, you may use aliases to not type for too long. Instead of a service, I write SVC. It perfectly works as well. I see what I have two services. One is Kubernetes as it is, and second is my Nginx SVC. Those are main things for us that's important to understand. And I guess for a service, I needed to switch type to node port. Otherwise, I will be not able to access those load balancers, but that's fine. We can switch. We always can change that. So we can take a look at the pods now. And those are my pods, but I want to know more about them. So I say, yes, all okay. I don't need all namespaces, but I definitely need a -o white. So I will see the nodes and others. So I see what all my pods are running at node 2, and that's pretty obvious. Node 3 is still dead. Maybe I'll have to add one more. And node 2 obviously is very for the one and only worker. So pods will be scheduled for the worker. It all runs with pods on my node 2. Here. And let me take a look. That's node 2. Very important command for us to know is kubectl describe. So it gets more information about one particular application or whatever you are interested in running. kubectl describe pod, and I will simply copy paste this value. Oops, wrong click. Good, so I see information about my running pod here. And what I want to see overall, namespace default, and that's not important. So where is it located? What's its internal kubectl IP address? It's controlled by replica set. You remember, I've noticed it. So we define it with deployment, and deployment controller creates replica set to establish replication for these services. We see details about the containers. So we have only one container. As discussed before, it has port 80. Host port is not allocated because of a service type wrong. And that should be enough for us to know. And now I want to change this service to make it available for us. Or you know what? I would better switch to my kubectl. I would better switch to my killer video application. So what I want to do first, I want to wipe out this application. How we do that first? Very easily. In this case, we say to create that, we say kubectl apply, and gave a file. And now when to delete that will be very easy. We just delete using the same file. In this case, file is located remotely on GitHub, but well, usually of course we work with normal files over local file system. So we can again say kubectl get pods, and there will be no pods in default namespace. The same relates to services and deployment. We have only Kubernetes, which is the default one. So we have our Kubernetes definitions. Now and they use node ports, so I can show you how they work. The command will be exactly the same, kubectl apply and -f, and what exactly I'm going to apply? I'm going to apply all files out of this folder. And something is wrong. Oh. Okay. That's fine. So I'm specifying the folder I'm going to apply, and kubectl goes. Okay, yeah, this one was created 2 years ago, so we have. It looks like we have to adjust the Kubernetes deployment for killer video, and we have problems with deployment, which is not a big deal because it's easy to fix, and I will fix that right now. For the deployment right here, it was apps v1, so no worries. And first deployment we have to fix is backend deployment YAML. And of course it has no nano. I hope it has Vim. Okay, that's better. So I only has to adjust this line. Boom, apps v1. Right quit, boom. Okay, better. Good. So, what's the benefit of this approach for files? One of them, I can easily replay the command. As long as there are some changes will be applied. But if there are no changes for some of the files, for example, service web is created already, it will be not touched. So it's very easy. Declarative manner. So those are configured, so nothing is changed. Those are not fixed yet, and something is not fine. Message required field selector in deployment spec. If you choose to ignore this error, validate files. Okay, I will use validate files. Or, yeah, that should work fine. No matches for kind of. Okay, yeah, it looks like that's a pretty obsolete. Yeah, we really have to update that for a newer version of the API of the Kubernetes. Regarding the things we have right now. So it requires selector. Okay, anyway. For the next step, I will fix this deployment file and you will have it in our, oops, wrong side. Where is it? Where is it? Killer video. Docker learning path adjusted for week 5. So it will work for you next half an hour. And as we are out of time for today, the last things we have to do, week 5 assignment. So first I speak to people from the Docker learning path now. I want you to get a little bit rest, read additional materials, and prepare for final assignment, which goes live tomorrow. You will receive an email if you register it for the Eventbrite for data for Docker learning path. If you will not, write me on Discord or email alexander.volishnev@datastacks.com. And now, for those who are still hungry and want to do more, if you go with only for this workshop and want to put your hands on more on a Kubernetes, I only happy to hear that. You can go with labs.play-with-kubernetes.com or install Kind or Minikube locally and use application from week 2 or week 3 of this learning path and run it in Kubernetes. And it may be not easy in the beginning, so there are 2 options. Or you may want to use Compose to convert Docker Compose files, or you may want to write Kubernetes manifests manually. And I would suggest to go basically both, because they give different experience. If you have time, that will be great. If something doesn't work for you, ask us at the Discord. You don't need to install Discord. For that, you can do it in browser. And basically, that's it for today. So,
it was a great session.
Yeah, thank you so much. Thank you for your help. It's always pleasure. And most of all, thank you, every one of the attendees. I see so many people stayed with us till the very end. That's incredible. We are always happy. And see you soon.
Thank you very much.